In the lesson today, we're going to have more practice factoring. We did a lot of practice last time, especially working with the greatest common factor and looking at how we can factor by grouping and factor different trinomials. And in this first part, we're going to talk about factoring quartic polynomials, which are fourth degree polynomials. Okay, a quartic polynomial is of the form ax to the fourth plus cx squared plus e. And at first glance, it doesn't look like that we're factoring a quadratic, but in a sense we really are. And so in this example, we have x to the fourth minus 4x squared minus 12. And again, at first glance, it doesn't appear that we're factoring a quadratic, but it kind of really is. Taking a closer look at the exponents, the power on the leading term is 4, the power on the middle term is 2, which is half of 4. And with regular quadratics, we would have powers of 2 and 1, where 1 is half of 2. So this polynomial follows the quadratic pattern. It is a quadratic in x squared rather than just in x. So we can think of this, instead of having x to the fourth, that's the same as x squared squared. Okay, and then we have minus 4x squared minus 12, where we could compare that to a regular quadratic. It would be x squared minus 4x minus 12. In this case, all we did was square both of these terms here in the middle. Okay, so we're going to break this up like we would a normal quadratic with our parentheses. Okay, with this example, we would have our parentheses where we would have an x out front. But since we have x to the fourth here, we're going to break this up, and inside of our parentheses, we're going to start with x squareds. Okay, and then my process is the same as what I've been doing before in order to factor a trinomial. I'm taking the coefficients of the a term and the c term. In this case, the a term is a 1. The c term is a negative 12, and if I multiply them together, that's going to give me negative 12. So I'm going to look for factors of negative 12 that are going to add up to my b term here of negative 4. Okay, so thinking out loud here, well, they have to have a product of negative 12, they have to add up to negative 4. Well, those two factors are going to have to be negative 2 and positive 6. And so if I were to plug those values in, now I'm going to have x squared minus 2 times x squared plus 6. Okay, so you still need to check to see if there's any further factoring possible. In this case, we can't factor any more than we already have. There is no GCF or differences of two squares, and so that's how we would factor this quartic polynomial. So what we're going to do, we're going to practice that underneath in example 2. They show us again 4x to the fourth power minus 25. This is a difference of two perfect squares. To make 4x to the fourth, we would have 2x squared times 2x squared. And to make that negative 25, we would have a negative 5 and a positive 5. And since there is no middle term, they have to add up to 0, which negative 5 and positive 5 do. So this would be the factored form of that difference of perfect squares. In example number 3, we're going to factor k to the fourth minus 2k squared minus 3. So I'm going to start by taking my parentheses, and to make k to the fourth power, I'm going to need k squared times k squared. Okay, my coefficient out front is a 1. 1 times negative 3 is negative 3. So I need factors of negative 3 that are going to add up to negative 2. Okay, well that's going to have to be negative 3 and positive 1. And so that's how I would factor this quartic polynomial. In example number 3, I have 2b to the fourth power plus 17b squared plus 21. And I want to try to factor that quartic polynomial. And looking at it right now, I don't see any GCF that I would be able to factor out. So I'm just going to try to factor this polynomial the way that I would a normal quadratic. And so I'm looking at my coefficient out front. I have a 2 times the c term of 21. 2 times 21 is 42. Okay, so I need to have factors of 42 that are going to add up to 17. Okay, and I'm going to think about my factors of 42. I know I could do 1 times 42. I could do 2 times 21. I could do 3 times 14. I could do 6 times 7. All of those are different ways that I could multiply to make 42. And the ones that are going to add up to 17 are right here with the positive 3 and the positive 14. So I'm going to rewrite this as 2b to the fourth power. And instead of plus 17b squared, I'm going to rewrite it as plus 14b squared plus 3b b squared plus 21. Okay, and again, the 3 and the 14 came from the fact that those are going to add up to 17, so that's still the same as 17b squared. And now I'm going to factor by grouping like I did before. So I'm going to treat this example as one set, this example as another set, and I'm going to factor out the GCF in each part. The GCF of the first set here is going to be 2b to the second power. And when you factor out 2b to the second power, that's going to leave you with b squared plus 7. Okay, and now I'm going to factor out the GCF of the second part here, and that's going to be a positive 3. And when you factor out 3, that's going to leave you with b squared plus 7 as well. So looking here, I can see that my first factor is going to be b squared plus 7, and my second factor is going to be the GCFs, 2b squared plus 3. In the next section, we're going to focus on factoring quadratics completely. And whenever you have a quadratic that you want to factor completely, there's a series of steps that you should try to follow. Step 1 is factoring out a GCF if possible. If you look at all the terms and notice that they have something in common, factor that out right at the beginning. After that, after factoring out the GCF, it may be possible to factor again into two different binomials. Okay, so you should always look to see if you have a trinomial that you could factor into binomials. Factor a difference between two squares as many times as possible. So I'll do a couple of examples with you here. In this first example, looking at these three terms in that polynomial, I notice that they have a GCF of 2. So I'm going to start by factoring out the GCF of 2. When you factor out the 2, that's going to leave you with x squared plus 6x plus 9. And now I'm looking at this trinomial, and I'm looking to see if I can factor it into two binomials. So I notice here that I'm going to have, okay, if I think about that as a 1, 1 times 9 is 9. I need a factor of 9 that are going to add up to 6. And I know that that's positive 3 and positive 3. So I'm going to have my 2 out front, and then I'm going to factor that trinomial into two binomials. So I'll put my x's in front. And again, my factors of 9 that add up to 6 are positive 3 and positive 3. And now this has been factored completely. Nothing else can be factored any further. In the second example, again, I'm going to look and see if they have something in common first. Looking at these two terms, I notice that I could factor out x. When you factor out x, that's going to leave you with x squared minus 4. And now I'm going to look and see if I could factor this into binomials. And I notice that this is the difference of two perfect squares. So I'm going to have my x out front, and then I'm going to break this into two binomials. X is out in front. And since it's a difference of perfect squares, a difference of 4 on this, I'm going to have minus 2 and plus 2. And now that has been factored completely. So again, start by looking to see if you can factor out a GCF. After that, look and see if you can factor into two different binomials.